In this section, I will be talking about a very basic concept when it comes to the time value of money or the mathematics of money that we just explained the introduction to it, which is the cash flow diagram. Now, by definition, a cash flow diagram under the subject of the time value of money or the mathematics of money aims and its goal to provide a graphical means for describing situations in which time intersect and interact with interests. So the situation when there is an interest and the time interact, that's what we as a cash flow diagram will be able to help us understand better with these situations. Moreover, developing an appropriate cash flow diagram is often a very critical step in solving any type of engineering economy analysis. For our course, we are more focusing on the construction management and the construction engineering point of view. So, let's have a look at the basic concept, or what we can refer to as the main elements of the cash flow diagram, which we will use to build on for our coming modules later. So we start by drawing the timeline of the diagram, which this will be divided into intervals or periods of times or interest periods, similar to what I explained in previous modules. So from the x-axis, and there is only x-axis and then the bars in the y-axis, highlighting first the timeline as I explained with, let's say, the number timeline from a 0, 1, 2, 3, 4, all the way to an n period of time. These periods could be, as I explained before, days or weeks or months or quarters, semi-annuals or yearly. Most of the classes or most of the modules and the examples, I might be focusing either on monthly or annual. But I highlighted if we have less or more intervals in that here, what to do from the APY, from a nominal and effective interest rate. So this is the first step. Second is P. N, as I explained, the number of compound periods, the interest periods. P is a present sum of money. If you remember, we talked about P a lot in previous modules, and this is what's the money we have today in hand. This is the present worth of the money. And after that, I want to highlight another term, which will be what we call or refer to uniform series, or A value. The A value here, as you can see in the cash flow diagram, is an end of period cash flow in a uniform series counting for an n period of time. And these A or installments are the same value for it, in order to say, okay, we have the same A for this number of periods of times, and we will talk about it in much more details in the next slide. Next, another term in the cash flow diagram we might be also dealing with, in addition to the P, to the number of intervals and A, is the F value, which is a future sum of money, the future value. And if you remember, we also talked about the F value or the future value, and we connected the F value to the P value with an I interest rate on this number of interest periods until N. So now we have an idea about the P value, which is the present value of a money today. Let's study next how we can calculate the equivalent A values, of a given P value. The A value here, sometimes we refer to it as the uniform series values. or if it is the timeline here, if it is yearly by year, year by year, this sometimes we refer to it as annuities or annuity. So after we will study, excuse me, after we're gonna study how we can connect the A values to the P value, we will then move forward to understand and to calculate the equivalent future value F of an A series value. So I will focus to connect the relation between the P and how we can convert it to A's or vice versa. And next we will work on study on how we can calculate or find out the equivalent values of an A's with the linkage to an F. So let's move forward then to focus on the next topic, which is the uniform series values. The definition of a uniform series values is a series of equal, or are a series of equal payments or receipts paid out from a payment point of view or received from receipts in a sequence over a period of time. So let's say, I like always to give examples with numbers to better digest this kind of information and better link what's and how we came up with formulas to calculate such A values and P values and F values, similar to what I did in the previous slides and modules when we talked about the simple interest rate and the compound interest rate and so on. So let's say on this, to understand it better, that you want to buy a construction equipment or a tractor or any piece of equipment that you will use in your project or in your company, or a car or any kind of tool that you will be using. Let's assume that this piece of equipment is worth around $30,000. So one option you have in mind here or in hand is to pay the full amount of the $30,000 to buy that specific piece of equipment today, which this is what we referred to in the previous slide, the value P from the present worth of the money. So from the previous slide, I'm gonna highlight, I highlighted P and A and F, and I will tell you that, okay, if to buy an equipment worth $30,000, one option is to pay for it today. This is the $30,000. Another option would be, mathematically speaking, to pay in the future the entire amount, which is equivalent to the future value, or F, from the cash flow diagram before, of this amount, 30,000, based on a specific monthly interest rate or annual interest rate. So if I tell you, at our example here, that the interest rate provided to you is, let's write it down so as we can follow up on that. So let's say we have an interest rate equal 10%, and this is compounded monthly. So speaking of that, that's mean each month, because this is a nominal interest rate. So this nominal interest rate, I can either convert it to an effective or find the interest rate per month. To find the interest rate per month, that means that each month the interest I is equal to 10% divided by 12 months per year, which is equal 0.833%. So I, from monthly point of view, will be 10% divided by 12 months per year, which will be equal 0.833%. Now, in this case, in our example that we are building up here, We have a monthly interest rate of 0.833%. So let's assume that the payment for the future value of the 30,000 is due in 36 months from now. So N will be equal to 36 months. Then the future sum value you need to pay in 36 months from today can be found using the equation that we explained earlier in the course, which is the following equation. We have either f equal to the p times 1 plus I to the power of n, or the other way around. But for this value, we're trying to find, let's do this. Let's have the equation written here, p1 plus I to the power of n. And this is fn.